I'm Colin Walls, and I'm here once again to talk about embedded software. Today I want to talk about optimization. This is an important word in the vocabulary of embedded developers. We talk in terms of optimized compilers, and we all understand that having things optimized is a good thing. But what does it really mean? Most of the time when we say optimized, we mean code optimized. So optimization of code is the critical thing. Now, for general computing, optimized code is just the best quality code that you can generate from a compiler. In the world of embedded, we look for more control. So optimization needs to have adjustments we can make. And at the simplest level, we are optimizing our code to run as fast as possible or be as small as possible, or some combination of those things. And that's fine. We have that control. Given application has different needs. But it goes further than that. There are other kinds of optimization which are less widely considered, one of which is data optimization. Now, you might think data is data, and how can you optimize it? Well, there are different ways of putting data into memory. We can put the data in memory in what we call unpacked form, which means that if you have a somewhat complex data structure, each element is on a word boundary and therefore can be accessed quite rapidly. So that's unpacked data. That is data optimized for access speed. The alternative is packed data. This is data which is put into memory using consecutive bytes to store everything, which may be a little more complex to extract from memory when it's needed. So it's efficient in terms of storage, but less efficient in terms of time. So this is data optimization. And normally what happens is there is a switch on the compiler, and that switch will let us select whether we have packed or unpacked data. Again, very commonly, there are some extra keywords, and these keywords enable us to override that optimization. So for example, if you have asked the compiler to generate unpacked data for speed, and you have a particularly large data structure which you want to pack into memory, then you would declare it as being packed. Alternatively, if you are by default packing all your data into memory and you had a particular structure you wanted to access quickly, so you wanted it unpacked, you would declare it unpacked. So of course you would never use both keywords in a given application. There's another aspect where optimization is quite interesting, and that is power. Increasingly, we are building systems where the power consumption is a significant factor. And this is important from the software perspective, because software can have a lot of influence over the power consumption of an embedded system. At the simplest level, if you look at the code generated by a compiler, there is the possibility that small code will use less memory, and less memory means less power. Also, fast code will use less CPU power to get a given job done. So that's more efficient. Both of these are ways of saving energy. There are other facilities which you might have on a device to save energy, but from the compiler's perspective, generating the code in a form which has the smallest energy footprint, if you like, is the best way. And maybe I can picture a switch on a compiler which is optimized for power. I haven't seen it yet, but I foresee that possibility. So it's interesting. We've now reached a point where we can see a three-way tension between three different factors. We can optimize for speed, we can optimize for size, we can optimize for power. This is not necessarily a conflict, but there is a tension between them, and we have to decide which is our priority in any given instance. So, optimization, much bigger subject than it might initially have seemed. There are many more details to look at, and perhaps that'll be a subject for another day. But for now, I'll say goodbye and cheers till next time.